So hi, this is the first video in my channel. So brief introduction to my channel. My channel is for international students who are preparing for IGCSE exams and A-level exams of different boards. So for now, I'll start with the Edexcel boards, and the subject is chemistry. I'm going to cover all the specification of this subject. So for now, we will start with Unit 1. Unit 1, what is this? Yeah, Unit 1, Chapter 1. So this chapter is the principles of chemistry. This consists of 10 chapters. This is the name of the unit. And today we will start with state of matter. With chapter 1, state of matter is a very easy subject. It's a very easy chapter. It's one of the easiest chapter of this course. So we need to know what is a matter. A matter is particles. So these particles can be in different forms, either solid, liquid, or gas. An example of it, we can't walk through a brick wall, but you can move with some resistance it pushes against you through water. Moving through air is easy. It is something involved with the force of attraction between particles. Force attraction between particles in the brick wall, which is a solid, is high, whereas in liquid, it is a little less, it is much less, whereas in gas, it is almost non-existent. That's why moving is easy. And when you melt most solids, their volume increases slightly. Most liquids are less dense than the solids they come from. Why the volume increase when we melt solids? Because solids are denser than liquid, right? So when we melt the solid, the density decreases, whereas the volume increases. That's why it has much volume than solid. So if you boil 5 centimeter cube of water, the steam will fall an average bucket. It is the same principle. The density of water is more than gas. That's why when we boil the liquid, the volume will increase, which in this case 5 centimeter cube of water can fill an average bucket. Now we here have the arrangement of particles. There's really no need to read all these words. You just need to understand a little of it, understand like the main idea of it, which is I like to separate it into categories. So we here got the arrangement. Sorry, the pen is so thick. Got arrangement and movement and force of attraction. So in solid forces of attraction is high. Why? Sorry, let's start with the arrangement. The arrangement in solid is what is regular. It's arranged in a regular pattern. What is the movement of particles? It does not move, it barely vibrates. Kinetic energy is low. And force of attraction between particles is high. That's why it's arranged in regular pattern. And you can see here that all the particles are touching each other. The arrangement is regular, and they are packed. The arrangement is packed and regular. Here we got to observe in the liquid. Liquid and gas are actually quite similar, just that gas is more exaggerated than liquid. You can think of it this way. So where's the arrangement of particles in liquid randomly arranged? What is the movement of between particles? Particles slide around each other. Kinetic energy higher than gas, higher than solid. And where's the next? Yeah, and then here we got the gas. The gas right here, it is randomly arranged, very randomly arranged. Kinetic energy is high. Movement of particles, random movements, intermolecular force of attraction, almost none. Unlike liquid have some intermolecular force of attraction. Particles are touching. This here we covered all this thing. And then here we get the interconversion between the three states of matter. So we don't really need to read the words, we just need to observe this diagram. So from solid to liquid, we need to input energy, and the process is called melting. From liquid to solid, we need to cool the matter. We need to cool it, which means decreasing the kinetic energy so the particles move less, and intermolecular force between the particles increases, so the particles become packed, and this process is called freezing, and then it's become solid again. This is the second diagram. So there are two different ways where liquid can become a gas. The two ways that happens is called boiling and evaporation. What is the main difference between them? Both of them is liquid becoming a gas. So boiling occurs at a specific temperature. For example, in water, the boiling point is 100 degrees Celsius, whereas evaporation occurs at different range of temperatures, can occur below the boiling point. Why? Because the particles at the bottom, for example, this is a beaker, here we have the fire, the particles at the bottom, it's closer to the fire, right? Means it has the most kinetic energy. It will flow up to the surface, and the surface will start to evaporate, even if the whole liquid haven't hit the boiling point yet. This is called evaporation. So this is the main difference between them. So liquid becoming a gas is called boiling or evaporation, and it requires input of energy. Whereas from gas to liquid, it's require cooling down, called condensation. So the best example for condensation is when you take a shower, especially a hot shower, a hot bath. The window is cold and the bathroom is hot, and you close the windows, obviously, so the whole bathroom is full of steam from the hot water, from the full of the steam of water, and the window is cold. So when that steam hits the window, it's condensed, and you can see that water drops coming from it. Here we get something called from solid to gas. So the example you need to know here is carbon dioxide. So there's no such things really called liquid carbon dioxide. You can still obtain it, but obtaining it is so hard. It needs very high pressure to be obtained. For now, you don't need to know that. What you need to know is that the process from solid becoming a gas requires input of energy, and the process is called sublimation. Whereas from gas to solid, it requires cooling, as we know, and it's something called deposition. The example you need to know is carbon dioxide. The solid carbon dioxide is called dry ice. And that's pretty much all you need to know about conversions between solid to gas, solid and gas. So now, by knowing the boiling point or melting point of the state of matter, we can know what state it will be at different temperature. So a substance is a solid at temperature below its melting point. So we can observe, for example, the melting point of this substance is like, I don't know, 10 degrees Celsius, minus 10 degrees Celsius. It's the melting point, means anything below that, it is a solid. Anything below boiling point and above melting point, it is a liquid. And anything beyond boiling point, it is a gas. And that's pretty much what you need to know. And here we got diffusion. So what is the diffusion? The main definition you need to memorize is that diffusion is the movement of, what's wrong with this pen? Oh yeah, sorry, of particles from an area of high concentration to an area of low concentration. That is a formula you need to know. That it's pretty much will come in exams, but it's not that common. But that formula, like if you write that definition, you'll definitely get the mark. So it's super worth memorizing. So let's suppose someone's spill some ammonia in the air, ammonia gas. It will, after a few seconds, you can smell that the whole room got that smell of ammonia because it diffuses through the room. So that's the main definition of diffusion. So here we can observe, this is an experiment to demonstrate. Here we have bromine. Why bromine specifically? Because bromine got a color, so we can observe the diffusion. We can see the particles. We can see the bromine vapor. So here we have the air, and here we have the gas jar lid. So what happens if we remove that gas jar lid? We will see that the particle starts from bromine, which is have high concentration of bromine particles, start to travel to the air, and the air start to travel to the bromine. Why? Because here we have high concentration of air, and we have low concentration of air. Here we have low concentration of bromine. Here we have high concentration of bromine. So bromine will diffuse upward, air will diffuse downward. After some time, you will see that the color become uniform. And there's also an experiment of diffusion you need to know, which is diffusion of ammonia and hydrochloric acid. So the students, so first of all, we soak two cotton pads. This cotton we soak it with ammonia. This cotton we soak it with hydrochloric acid, and we will observe. So the ring form closer to hydrochloric acid. This ring is called ammonium chloride. Ammonium chloride. This is the name of the ring. Why does it so in this experiment we can see the speed of diffusion. So because the ring formed closer to hydrochloric acid, this means that ammonium particle diffuses faster than hydrochloric acid diffuses faster than hydrochloric acid particles. That's why the ring forms closer to it. So that's pretty much all you need to know. Here we got diffusion liquids and the dilution of color solution. We have covered from the bromine experiment. And solubility here. Solubility of solids. So when a solid dissolves in a liquid, the substance dissolved is called solute. The liquid it dissolved in it is called the solvent. The liquid form is called the solution. This is memorization. This is memorization, the solubility of solids. So, for example, I want to mix a salt with water. Water here is solvent, and the salt is a solute. I put the solute in the solvent, dissolve it, and then a solution of salt is formed. This is how you can demonstrate it. There's another term you need to know, which is saturated solution. What is the saturated solution? Saturated solution is a solution that cannot dissolve more solvent at a specific temperature. Saturated solution, the solution that cannot dissolve more solute at a specific temperature. I will write it down. Saturated solution is a solution that cannot dissolve more solvent at a specific temperature. This is when you write this definition in the exam, you have guaranteed your mark. And here is the end of double award. I will record a video later for triple award, which is chemistry only. Don't forget to like the video if you like the video if it helped you, and subscribe to my channel for me to continue. And don't forget to share it with your friends so that everyone can can gain from the thing. And the more support I get, the more I will improve, and more videos I will record, and more subjects I will cover, and hope it help you. And goodbye, see you later.